Here we have a 3D object that's created by rotating the region between the line y equals 8x and the vertical line x equals 1.25 around the vertical line x equals 2. And we're going to find the volume of this object. So what they mean by rotating the region between this line and this vertical line, so this line right here, this is this line right there, and this vertical line here is this vertical line right here. So the region that we're rotating around the green line, 360 degrees, is this region right here. And so what we're doing, the way that we get this three-dimensional object is we rotate this two-dimensional blue area here, 360 degrees, one full turn around the green line there. That gives us this odd shape. And now we'll find the volume of this shape, of this three-dimensional object. So here we have the formula that we'll use for that. And the first question I should ask is, why, or how do we know that it's a dy? Why is it not a dx? Why is it a dy? And the way to understand that conceptually is think about an arbitrary thin slice here. So I have this arbitrary thin slice. And now think about what the integral is going to do. It's going to add up all of these thin slices, and it's going to add them vertically. Since it's going to add them vertical, we need the vertical axis dy. So that's why it's a dy and not a dx. Now from the figure, you can see that we're going to add from y equals 0 to y equals 4. And so now the difficulty is figuring out what is this outer radius and what is the inner radius. So first, let's figure out this outer radius. Now the outer radius, this comes from the radius, right? If you think of a radius, it comes from the center of a circle. Right, so at this arbitrary y value here, at this arbitrary y value, we want this radius. Remember, the center is at the green line. So that the outer radius is the length of that red line there. So the outer radius is equal to, now, so the way to find this outer radius is, notice that this distance, right, from the y-axis to the green line there, that distance is 2. But we don't want all that distance. We want to take away that little bit there. So x equals 2 is the distance to, is that blue distance. So that's the 2 there. And now we want to take away the yellow distance. The yellow distance. Now what is that yellow distance? That, remember this this vertical, or this line right here, right? This is the line y equals 2x. But remember, we're integrating along the y-axis, so we don't want to put 8x there, right? We don't want that. We want to solve, so we have y equals 8x. We want to solve for x. Which gives us x equals 8 over y. So we have 8 over y there. So let me reiterate. we want to find this distance here. To find that distance is the difference between this full distance there of 2, take away this little bit right there. So our outer radius is 2 minus 8 over y. Now let's find our inner radius. So our inner radius, we want this little piece right there. Again, we're going to use a difference. So remember that blue gives us all the way from y equals 0 or x equals 0 to x equals 2. So that's a 2 there. Right, remember that green line is x equals 2. The green vertical line is at x equals 2. So the length of that blue line is 2, right? Because we're going in an x direction here. We're going horizontally. So the length of that blue line is 2. And now we want to subtract off all of that distance there. Well, that distance is 1.25. And that's how we set up the integral.